Good morning, all of you. Welcome to see Jayendra rank zone. We have completed already 11th group elements, that is alkali metals. Now we are going to discuss 12th group metals, that is alkaline earth metals. And in this lecture, we are going to discuss some more points regarding alkaline earth metals. So please listen carefully. And afterwards, we'll have question session. So let us start now. Yes. Compounds of calcium. So next point in the chapter is compounds of calcium now. Calcium oxide. First compound in calcium is calcium oxide. It is also called as quicklime. Calcium oxide is prepared by heating limestone, that is calcium carbonate, in a rotary kiln when calcium carbonate decomposes at 800 degrees C or 1070 kelvins. So calcium carbonate on heating strongly will form calcium oxide along with carbon dioxide gas. For greater completion of the decomposition of formed carbon dioxide should be removed immediately as the reaction is reversible. If you do the same reaction, in closed vessel, so it is reversible. The reaction is reversible. So to avoid that, carbon dioxide should be removed timely. Reaction is reversible. So to avoid this, the carbon dioxide should be removed immediately as the reaction is reversible. So this is called preparation of calcium oxide. Calcium oxide is a white amorphous solid. It absorbs atmospheric moisture and carbon dioxide. It is a white amorphous solid. It absorbs atmospheric moisture and carbon dioxide. So calcium oxide on reaction with water, it forms calcium hydroxide. And on reaction with carbon dioxide, again, it forms calcium carbonate. So calcium oxide reacts with water to form calcium hydroxide, which is also called as slaked lime. So this is called slaked lime. The reaction is called slaking of lime and is exothermic in nature. Exothermic means heat is liberated. Delta H is equal to negative. Heat is liberated. So this is a reaction, heat is liberated. In this reaction, heat is liberated. That's why it is also used as plaster of Paris. Next continuation. Calcium oxide is a basic oxide and so it combines with acids. So metallic oxides are basic in nature, already we know. Most of the metallic oxides, that is strongly electropositive metallic oxides, are basic in nature. So calcium oxide is also basic in nature and it is a basic oxide. So it combines with acids and acidic oxides. So calcium oxide combines silicon dioxide, which is acidic. This is acidic oxide because non-metallic oxides are acidic, and it forms calcium silicate. This is called calcium silicate. It is used in metallurgy. It is removed in the form of slag. It is used in the extraction of metals and it is removed in the form of slag. So it is called calcium silicate. Similarly, calcium oxide combines with phosphorus pentoxide, which is also acidic in nature and forms calcium phosphate. This is a salt actually. So acid and base. On heating with carbon at very high temperature, it forms calcium carbide. Very, very important. This calcium carbide calcium carbide in which carbon and calcium is related with C double bond C. So it is nothing but calcium carbide. This calcium carbide undergoes hydrolysis to form acetylene. Acetylene is an organic compound. It is also called as ethine. So very important compound you'll get from calcium. So calcium carbide on hydrolysis forms calcium hydroxide plus acetylene. These 3 moles of acetylene when passed through red hot iron, it forms benzene. It forms what? Benzene. So these 3 reactions are important. Reaction number 1, reaction number 2, and reaction number 3. These 3 reactions are important because they'll ask in the examination. Compound A on reaction with carbon forms calcium carbide plus carbon monoxide. This calcium carbide on hydrolysis forms compound B. Compound B, when passed through red hot iron tube, forms compound C. So what are A, B, and C? They'll ask in the examination. So that is question based on reactions. So definitely these 3 reactions are important. First reaction, calcium oxide on reaction with carbon, it forms calcium carbide along with carbon monoxide. This calcium carbide on hydrolysis forms calcium hydroxide along with ethane gas, that is acetylene gas. And this ethane gas or acetylene gas, 3 moles of acetylene when passed through a red hot iron tube, it forms benzene molecule. So starting with calcium oxide, it completes up to benzene. So all these reactions are very important. Like this linked reactions only they'll ask in the entrance examination. So be thorough with it. Next continuation. Calcium oxide is used in the manufacture of bleaching powder. What is bleaching powder formula? Calcium oxychloride, CaOCl2. Calcium oxychloride, it is called bleaching powder. And lime colors, cement, etc. Cement, very important for construction purposes. So calcium oxide is used in the manufacture of calcium oxide is used in the manufacture of cement. It is also used in metallurgy as basic lining for furnaces to withstand high temperatures. To withstand high temperatures, the metallic in the extraction of metals to withstand high temperatures. So this calcium oxide is used in metallurgy as basic lining for furnaces. It is used as water softening agent. It is used in the purification of sugar. So calcium oxide is also used in the purification of sugar. So all these points are very important. Please note it down. Next, very important compound next is calcium hydroxide. First we have done calcium oxide. Next we have calcium hydroxide. It is also called a slaked lime. So calcium hydroxide is prepared by passing calcium oxide in water. So this reaction already we have seen. So calcium oxide when dissolved in water it forms calcium hydroxide. It is also prepared by the action of caustic alkaline on a soluble calcium salt. That is alkaline means caustic means sodium hydroxide and alkaline salt means calcium chloride together combines to form calcium hydroxide and NaCl. This is also called as double decomposition reaction. Double decomposition reaction where Cl2 is exchanged with sodium and OH is exchanged with calcium. So like this you get. Next continuation, properties. Calcium hydroxide is also a white amorphous solid. Calcium hydroxide is sparingly soluble in water. However, its solubility decreases with the increase of temperature. Why? With the increase of temperature, the solubility of calcium hydroxide decreases, even though it is solid. Because from this, if you heat calcium hydroxide, you will be getting carbon dioxide. So that's why the solubility decreases with the increasing temperature. Aqueous solution of calcium hydroxide is known as lime water. Aqueous solution of calcium hydroxide is known as lime water. Suspension of calcium hydroxide in water is called milk of lime. Suspension is different than solution. Suspension means it is present as a part. So suspension of calcium hydroxide in water is called as milk of lime. If CO2 is passed through lime water, it turns milky. This is the only test for carbon dioxide. What is the test for carbon dioxide gas? To test carbon dioxide gas, if you pass it through lime water, it turns milky due to the formation of precipitate calcium carbonate. Due to the formation of precipitate calcium carbonate, it turns lime water milky. Which turns lime water milky? Carbon dioxide gas turns lime water milky. So CO test for CO2 is nothing but if you want to test whether the given gas is carbon dioxide, you simply have to pass it through lime water so that the lime water turns milky. If the lime water turns milky, it is confirmed that it is carbon dioxide gas only. Why? Because carbon dioxide converts lime water to turn milky due to the formation of precipitate calcium carbonate. Due to the formation of the precipitate called calcium carbonate. That's why it turns lime water milky. Next continuation. On passing excess of carbon dioxide, the precipitate formed gets dissolved due to the formation of calcium bicarbonate. So if you pass excess of carbon dioxide, it results in the formation of calcium bicarbonate. Slaked lime reacts with chlorine gas. It combines with chlorine gas to form bleaching powder. So bleaching powder forming hypochlorite, commonly called as bleaching powder. In bleaching powder, we have two chlorines. What is this? Calcium oxychloride. This is one chlorine, and this is another chlorine. So the oxygen state of one chlorine is -1, and the other chlorine is +1. This also they'll ask in examination. What is the oxygen state of chlorine? Two chlorines in bleaching powder, it is -1, +1 respectively. The oxygen state of two chlorine molecules in two chlorine atoms in bleaching powder is -1 +1 respectively. So this is called bleaching powder, calcium chloride plus water. Not this total is bleaching powder, only this is bleaching powder. So Slaker dry, how what is the preparation of bleaching powder? When calcium hydroxide combines with chlorine gas, it forms bleaching powder. It forms what? Bleaching powder. It is also called as calcium oxychloride. Calcium oxychloride is called bleaching powder. Here CaOCl2 taken twice is not there. It is just CaOCl2 only. This formula you have to change. It is just only CaOCl2. For O, no two Cls. So that's why the oxygen state of chlorine is -1, comma +1 respectively. Please note these points. Next continuation. Uses. Calcium hydroxide is used as whitewash for buildings. Simple, just like paint. But it is not paint, it is whitewash. Whitewash for buildings. For the manufacture of bleaching powder, that is calcium oxychloride. For the manufacture of soda lime. Soda lime is nothing but what? Soda lime is a mixture of calcium oxide plus sodium hydroxide. Calcium oxide plus soda lime plus sodium hydroxide is called, it is called as soda lime. It is used in preparation of mortar. Mortar is one part of slaked lime, three parts of sand and water. This mortar is used in the construction of buildings. Next, it is used in glass making, tanning industry, and for the purification of sugar. So calcium hydroxide is also used for the purification of sugar. So these are the major uses of calcium hydroxide. Next, calcium carbonate. Now in this lecture, we are going to discuss only about calcium compounds. Next, we have calcium carbonate. This is prepared by the carbonation of slaked lime. What is carbonation of slaked lime? Is slaked lime on reaction with carbon dioxide. This is slaked lime on reaction with carbon dioxide forms calcium carbonate, which is called as limestone and water. Carbon dioxide is not taken in excess as it may lead to the formation of calcium bicarbonate. So if you take calcium carbon dioxide in excess, it will result in the formation of calcium bicarbonate, but not calcium carbonate. Calcium carbonate can also be prepared by treating sodium carbonate with calcium chloride. Sodium carbonate with calcium chloride forms calcium carbonate plus sodium chloride. Double decomposition reaction. This is called what? Double decomposition reaction. Next. So these are the preparations of calcium carbonate. So calcium carbonate is done by two methods. One is from calcium chloride and along with sodium carbonate. Another is from slaked lime with carbon dioxide with not excess of carbon dioxide. If it is excess of carbon dioxide, it changes to calcium bicarbonate. Next, continuation. Properties. It is a white fluffy powder. This is insoluble in water. Calcium carbonate is insoluble in water, undergoes decomposition and forms calcium oxide and carbon dioxide. It reacts with dilute acids to liberate carbon dioxide gas. So calcium carbonate combines with dilute acids like H2SO4 and HCl and resulting in the formation of their salt, that is calcium chloride, calcium sulfate. These are the two salts along with the liberation of carbon dioxide. Carbon dioxide liberation is common from calcium carbonate. Next continuation. Uses. So calcium carbonate is used in the manufacture of quicklime, washing soda, cement, glass, etc. It is used as basic flux. What is basic flux? Actually, I already told you, is used as basic flux in metallurgy because it will combine calcium carbonate on heating forms calcium oxide plus carbon dioxide. And this calcium oxide combines with acidic impurity. Basic flux is used to remove acidic impurity. Basic flux is used to remove acidic impurity. So it combines with silicon dioxide as impurity and forms calcium silicate. So that's why this is called flux plus gain is equal to slag. This is called gain. Gain means impurity. It is called slag. So flux plus gain is equal to slag. So calcium oxide is basic flux, which is used in metallurgy to remove acidic impurities. To remove acidic impurities. So please note this point. To remove acidic impurities in the metals, we have to use basic flux. To remove acidic impurities in metals, we have to use basic flux. So this is called calcium silicate. It is also used in paints, toothpaste, distempers, cosmetic, etc. It is used as medicine for indigestion. calcium carbonate is used as medicine for indigestion. So these are the major use of calcium carbonate. Next we have next compound calcium sulfate. CaSO4.2H2. It is also called as gypsum. Hydrated calcium sulfate is called gypsum. Calcium sulfate dihydrate is called as gypsum. It is prepared by the action of sulfuric acid on calcium chloride. So on any soluble calcium salt. So soluble, it is not soluble, it is soluble calcium salt. So calcium chloride on reaction sulfuric acid forms calcium sulfate plus hydrochloric acid. So this calcium sulfate along with water is called gypsum. Calcium sulfate hemihydrate is called, very important, plaster of Paris. It is used for decoration purpose, even for injuries also. Calcium sulfate hemihydrate is also called as plaster of Paris. So plaster of Paris, when gypsum is heated at 120 degrees C, it forms dead burnt plaster. It forms dead burnt plaster. What is the use of this plaster of Paris? Suppose usually false ceiling is done by the means of false ceiling. So false ceiling means what? It is nothing but decoration of hall. So false ceiling is done by plaster of Paris at homes. Is done by plaster of Paris at homes. Is for decorative purpose, looking good. So false ceiling will do. Next, first one, second one. This plaster of Paris is used in plaster of Paris. It forms plaster of Paris is also used for treatment of bone fractures, bone fractures in our body during accident. So this plaster of Paris is used as fall sealing, bone fracturing also. Next continuation. POP. This is called plaster of Paris. Reacts with water and sets a hard mass after some time. Setting of plaster of Paris involves two steps as shown. First, gypsum is heated. Along with water, it forms orthorhombic gypsum, and hardening by the removal of two water molecules, it forms monoclinic gypsum. So this hard mass is nothing but plaster of Paris. So plaster of Paris combines with water and sets to a hard mass after some time. So setting of plaster of Paris involves two steps as shown in the figure. So you can see here. So this hard mass is nothing but strengthening. Next we have cement. Mixture of clay. What is cement composition? They will definitely ask in examination. Mixture of clay, calcium carbonate and water when strongly heated and allowed to stand, it hardens to a stone-like mass. This is called as Portland cement. What is the composition of Portland cement is important. The average composition of Portland cement is it consisting of 50 to 60% calcium oxide, 20 to 25% sand, that is silicon dioxide, mixture of clay, calcium carbonate and water. So and aluminum oxide 5 to 10%, magnesium oxide 2 to 3%, ferric oxide 1 to 2%, and sulfur trioxide 1 to 2%. So these are the composition of Portland cement. Very, very important. They'll ask in the entrance exams the composition of Portland cement. So mainly it consisting of calcium oxide, silicon dioxide, and aluminum oxide. Remaining all the traces, that is magnesium oxide, ferric oxide, and sulfur dioxide is in less quantity, but majority it consisting of calcium oxide, silicon dioxide, and aluminum oxide. Calcium dioxide, silicon dioxide, and aluminum oxide. These are the things useful in the Portland cement. Next continuation. Important ingredients present in Portland cement are dicalcium silicate, tricalcium silicate 51%, tricalcium aluminate 11%. So they combine with calcium, that is silicon dioxide, aluminum oxide will combine with calcium and forms tricalcium silicate, dicalcium silicate, and tricalcium aluminate. Along with this, we add gypsum for better hardening of cement. So very, very important. Cement, definitely you'll get one question based on cement. What are the use of cement? For multiple types of constructions, for preparing reinforced concrete cement. So we already know cement is mainly used for construction purposes. Next, we have biological importance of magnesium and calcium. Biological importance of magnesium and calcium. Human body contains about 25 grams of magnesium and 1200 grams of calcium. Calcium in the form of bones. Very important. These two are vital for our human body. The daily requirement is from 200 to 300 milligrams both. Magnesium is used as cofactor for phosphate transfer in ATP, adenylene triphosphine. Adenylene triphosphine. This neat students can better understand. So magnesium is used as cofactor for phosphate transfer in cofactor for phosphate transfer in ATP. Magnesium is present to chlorophyll that also is responsible for the absorption of light in plants. Already we know chlorophyll is nothing but in the process of photosynthesis. Plants prepare their own food by the means of a pigment called chlorophyll. In chlorophyll, magnesium is present. What is present? Which metal is present in magnesium chlorophyll? It is magnesium. Which metal is present in chlorophyll? It is magnesium. Calcium is present to bones and teeth. It is also useful for neuromuscular function and neural transmission. So calcium is very vital in our body. Calcium is also helpful in blood coagulation. Coagulation means blood clotting. Coagulation. This you'll be getting this coagulation word you will be getting in 12th class surface chemistry. So these are the biological importance of magnesium and calcium. Now let us see questions based on this lesson, that is today's concept. I'm taking in a new slide so that it will be shared easily. So I'm doing it now. Yes. So new slide is being shared. So let us start now. Yes. Now questions MCQs. MCQs on alkaline earth metals. Alkaline earth metals. Let us start now. Question number one. So far we are not done, that's fine. Plaster of Paris is plaster of Paris is. What is the formula they are asking? Option A, CaSO4 dot 2H2O. Option B, CaSO4 dot half H2O, that is calcium sulfate. Option C, CaSO4 CaCO3 dot CaCO3. And option D, it is CaSO4 dot 5H2O. So as you know the answer, it is nothing but CaSO4 dot, sorry, this is CaSO4 half H2O. This is called plaster of Paris. Plaster of Paris. From gypsum you will get it. And first option is called gypsum. This is called what? Gypsum. So from gypsum, it will be prepared plaster of Paris. Next question number two. Calcium carbide reacts with water, reacts with water to form, to give. Option A, it is methane. Option B, ethane. Option C, ethylene, ethylene. And option D, it is acetylene. So what is the answer now? It's very easy. So calcium carbide on hydrolysis forms acetylene. The reaction is CaC2 plus water gives rise to CaO is taken twice plus C2H2. So this is called acetylene. Next, third question. Beryllium carbide. Beryllium carbide. This you have to remember. This is in the previous lecture. Beryllium carbide and aluminum carbide. Aluminum carbide. Carbide on hydrolysis. On hydrolysis gives? Option A, it is methane. Option B, it is ethane. Option C, it is ethylene. And option D, it is acetylene. So beryllium carbide and calcium aluminum carbide on hydrolysis gives, as we already know, it is methane. So the reaction is, you can see Be2C plus water forms CH4 plus beryllium hydroxide. You can see the balancing later on. So for understanding I'm giving. So this is called methane gas, methane. These two questions are very important in the examination, entrance exams. Next question. Question number 3. Question number 4, sorry. Numbers you don't worry. Next question number 4. Beryllium shows beryllium and lithium, sorry. I'll just rub it. Question number 4. Beryllium and lithium shows diagonal relationship with dash and dash respectively. Option A, it is calcium and magnesium. Option B, it is magnesium and calcium. Option C, it is aluminium and magnesium. And option D, it is magnesium and aluminum respectively. So what is the answer? It's very simple. See, we already know aluminium and magnesium, because beryllium is with aluminium and lithium is with magnesium. So this will show diagonal relationship with each other. Next question, question number 5. Mixture of calcium cyanide, CaCN2, and carbon is called, calcium cyanide and carbon is called. Option A, it is barytes. Option B, it is anhydrite. Option C, it is nitroline. Very, very important, this compound. And option D, it is gypsum. So what is the answer? Mixture of calcium cyanide and carbon is called nitroline. Very, very important, they'll ask. Mixture of calcium cyanide and carbon is called nitroline. It is called what? Nitroline. Next. Question number 6. Ripening of fruits. Ripening of fruits can be carried out in the presence of option A, it is sodium sulfate. Option B, it is sodium chloride. Option C, it is calcium chloride. And option D, it is calcium carbide. So the answer for this right answer is ripening of fruits. Ripening of fruits can be carried out in the presence of calcium carbide. That's why it's a carbide, calcium carbide. Next question. Question number 7. Of the following, of the following, the ampho- amphoteric oxide is amphoteric oxide. Amphoteric oxide is option A, it is lithium hydroxide, sorry, calcium hydroxide. Option B, it is sodium hydroxide. Option C, it is beryllium hydroxide. And option D, it is lithium hydroxide. So amphoteric oxide means it is beryllium hydroxide only. Beryllium hydroxide is amphoteric in nature. So answer is C. Next question. Question number 8. So like this, you'll get entrance exam questions, simple questions. But by that time, you have to remember that is most important. Solubility of alkaline earth metals carbonates. Solubility of alkaline earth metal carbonates. Alkaline earth metal carbonates in water is as follows. Option A, it is beryllium carbonate greater than magnesium carbonate greater than calcium carbonate greater than barium carbonate. Option B, it is beryllium carbonate. This is very important question. Beryllium carbonate greater than calcium carbonate, sorry, greater than magnesium carbonate greater than barium carbonate. Option C, beryllium carbonate less than magnesium carbonate less than calcium carbonate less than barium carbonate. And option D, barium carbonate less than beryllium carbonate less than magnesium carbonate less than calcium carbonate. So these are the four options we have. So the solubility of alkaline earth metal carbonates, solubility of alkaline earth metal carbonates in water is as follows. So which is the right option we have to say. So solubility, the answer is first option. The solubility decreases down the group. Solubility decreases down the group. Since solubility decreases down the group, so answer is first option. Barium carbonate is more soluble than magnesium, than calcium, than barium carbonate because solubility decreases down the group. Solubility of carbonates decreases down the group of second. So this is the question. Next question. So all these questions will be there in the videos. No need to worry. Next question number 9. Question number 9. Magnesium. Magnesium combines with nitrogen to form magnesium nitride Mg3N2 magnesium nitride which which reacts with water to form a colorless gas to form a colorless gas. The gas is very important question. This is the gas is option A, it is ammonia. Option B, it is nitrous oxide, which is also called as laughing gas. Option C, it is nitric oxide, NO. And option D, it is N2O, NO2, nitrogen dioxide. So there are given 4 options. You need to start with this. So magnesium combines with nitrogen to form magnesium nitrate. This already we know. And this magnesium nitrate, when combined with water, it forms a colorless gas, which is called as the gas is. So the gas is, I'm writing the solution here. It is ammonia. So magnesium combines with nitrogen and forms magnesium nitride. This magnesium nitride combines with water and forms magnesium hydroxide along with ammonia. So you can say 3 water molecules, magnesium hydroxide along with ammonia. So balancing and all you can do. So this is called ammonia gas. Next question. Question number 10. Question number 10 now. The most abundant alkaline earth metal. The most abundant alkaline earth metal. The most abundant alkaline earth metal in the Earth's crust is, in the Earth's crust is option A, it is beryllium. Option B, it is magnesium. Option C, it is calcium. And option D, it is strontium. So straight away we can say either magnesium or calcium. But in these two also, which is more, let us see now. So beryllium, magnesium, calcium, and so on. So beryllium, magnesium, calcium, strontium they are given. So answer for this right answer is calcium. As I already told you, either magnesium will be or calcium, but in between magnesium and calcium also, calcium is most abundant. Next question. Question number 11. Because since alkaline earth metals, we didn't do any questions, so that's why I want to do more questions from this, so that it will be easy for us to understand. Next question. The oxygen state, this question is quite interesting. The oxidation state, the oxygen state of most electronegative atoms. Remember the questions. Most electronegative atoms, electronegative elements, most electronegative elements most electronegative elements in the parts of the reaction, in the products of the reaction. They are not asking parts, they are asking oxygen state of the parts. So in the parts of the reaction of barium peroxide with dilute sulfuric acid. Barium peroxide with dilute sulfuric acid. So definitely should know this reaction, then only we can identify the parts and we can write the in that parts most electronegative elements oxygen states. Otherwise you cannot proceed to this equation. So first option it is 0 and -1. Second option it is -1 and -2. Third option it is -2 and 0. And fourth option it is -2 and +1. So which is the right option you have to check. So first you should know this reaction, then only you can write it easily. Otherwise you cannot write. So here barium peroxide on reaction with dilute sulfuric acid. So what happens when peroxides combine with sulfuric acid, dilute acids? What does it forms? So what does it forms? You have to write the equation. So I'm writing the equation on the board. Just note it down. So barium peroxide on reaction with sulfuric acid. I'm just writing it now. Just note it down. Yes. Just writing the equation first. Please note down. So barium peroxide formula is BaO2. On reaction with dilute sulfuric acid, it forms barium sulfate along with hydrogen peroxide. Barium sulfate along with hydrogen peroxide. So the oxygen state in barium sulfate, the oxygen state of oxygen is in barium sulfate. So most electronegative element of the parts they are asking. So most electronegative is oxygen. So in barium sulfate, the oxygen state of oxygen is oxygen state of oxidation number of oxygen is already we know it is -2. And in hydrogen peroxide, the oxygen state of oxygen is in peroxide, the oxygen state of the oxidation number of oxygen is -1. So answer is -2 and -1. So -1 and -2. So option, second option it is B. -2 and -1. Respectively, they are not given, so you can write interchange any point. If they are given respectively, then -2 and -1 should be the answer. So like these questions you will expect in the examination. Next question, question number 12. Question number 12. Very important question. So here it is, space is not enough. So which are the following forms covalent compounds? Which of the following forms covalent compounds? Which are the following forms covalent compounds? Option A, it is beryllium. Option B, it is magnesium. Option C, it is calcium. And option D, it is strontium. Since already we know in alkaline earth metals, beryllium forms covalent compounds. Beryllium forms covalent compounds. In alkali earth metals, lithium forms covalent compounds. Lithium forms covalent compounds. Next, question number 13. This 13th question is very important. I'll just write it here. Beryllium and aluminium. Beryllium and aluminium exhibit many properties which are similar. Exhibit many properties which are similar, but the two elements differ in. But the two elements differs in option A, forming covalent bonds. Option B, it is forming polymeric hydrates. Forming polymeric hydrates. So we have seen beryllium hydrate and aluminum hydrate. Polymeric means big chain. Polymeric hydrates. Option C, exhibiting maximum covalency in compounds. Exhibiting maximum covalency in compounds. And option D, exhibiting amphoteric nature in the oxides. Exhibiting amphoteric nature. Amphoteric nature in their THEIR, their oxides. So this question is most important. Already we know beryllium and aluminium exhibits. Beryllium and aluminium have diagonal relationship because most of the properties are similar. So in certain properties they are not similar. So what are those properties we need to identify? That is exhibiting maximum covalency. What is the answer? First option, forming covalent bonds, it is similar. Forming polymeric hydrates like aluminum hydrate and beryllium hydrate, they form polymeric hydrates. Exhibiting maximum covalence in compounds is not similar because aluminum covalency maximum goes up to 6. Aluminum can form covalence up to 6, whereas beryllium can form maximum 4. So exhibiting maximum covalence in compounds, they differ. And exhibiting amphoteric nature in the oxides, it is also correct. So only third option is not, third option, they differ. What is that? Exhibiting maximum covalency in compounds. Exhibiting maximum covalency in compounds. Next question. So like these questions, they are very important concept-based questions. Next question, 14th question. Let us start now. Magnesium is an important component. Magnesium is an important component of which biomolecule occurring extensively in living world. Of which biomolecule? Of which biomolecule occurring extensively, occurring extensively in living world? Option A, it is hemoglobin. Option B, it is ATP, adrenaline triphosphate. Option C, it is chlorophyll. And option D, it is vitamin B12, vitamin B12. So in which biomolecule it is present extensively? In which biomolecule it is present extensively? So answer for this is, we already know it is chlorophyll. So magnesium is present in chlorophyll. Very, very important question. Next question. Question number 15. Let us start now. So now we are doing previous IIT advanced questions. Let us see now previous IIT advanced questions. Simple it is given. Question number 1. Calcium. This is question number 15. Now we are doing previous IIT questions. Old book. So let us see, because this will be important for JEE mains. So previous IIT questions now we are doing. Calcium is obtained by option A, electrolysis of molten calcium chloride, electrolysis of molten calcium chloride. Option B, electrolysis of solution of calcium chloride in water. Option C, reduction of calcium chloride with carbon, reduction of calcium chloride with the carbon. And option D, roasting of limestone. So it is quite simple. This is IIT 1996 question. So I'm writing solution here, 1980 actually. So solution now. Electrolysis of molten calcium chloride is the answer, because if you take electrolysis of calcium chloride in water, so calcium chloride electrolysis, what happens? It forms calcium ions plus chlorine molecule, chlorine ions. So these calcium ions gains 2 electrons and forms calcium metal at cathode, and chlorine ions, 2 chlorine minus ions, loses 2 electrons and forms chlorine molecule plus 2 electrons, that is at anode. So at cathode reduction takes place and at anode oxidation takes place. So this is possible only if you take molten calcium chloride, only molten calcium chloride. If you take calcium chloride with water, so they will form calcium ions and chlorine ions, as well as water also dissociates to form H plus ions and OH minus ions. So the desired product will be hydrogen. So hydrogen will go and deposit cathode in place of calcium. So that's why it is not possible. So answer is only first option, molten CaCl2. High electropositive metals are prepared only by the electrolysis of their fused solutions. Highly electropositive metals are prepared by the electrolysis of their fused salt solutions. Fused salt solution or molten salt solution only. That point you have to remember carefully. Next question. Question number 16. We'll discuss maximum questions from this. The following compounds have been arranged. The following compounds have been arranged in the order of their increasing thermal stabilities. Increasing thermal stabilities. Increasing thermal stabilities. The correct order is, identify the correct order. Identify the correct order. Option A. So they are given, just wait. They are given potassium carbonate 1, magnesium carbonate 2 in Roman numbers, calcium carbonate 3 in Roman numbers, and barium carbonate is 4. So they have assigned each and everything. Now option A directly, 1 is less than 2, less than 3, less than 4. Option B, 4 is less than 2, 4 is less than 2, less than 3, less than 1, increasing order. Next, option C, 4 is less than 2, 2 is less than 1, 1 is less than 3. And option D, we have 2 is less than 4, less than 3, less than 1. So we need to see the right answer. So question number 16, the following compounds have been arranged. The following compounds have been arranged in the increasing order of their thermal stabilities. Thermal stabilities is important here. So they have been arranged in the increasing order of their thermal stabilities, and we need to write the right answer. So option A, it is 1 is less than 2 is less than 3 is less than 4. And option B, it is 4 is less than 2 is less than 3 is less than 1. So already we know. Now I'm writing the solution. Thermal stability thermal stabilities follows the order for in case of alkaline metal carbonates. So first one, you have barium carbonate is less than magnesium carbonate is less than calcium carbonate is less than potassium carbonate. See here, they have given potassium carbonate. So the thermal stability increases down the group, and here the answer is decreases down the group. So answer is first barium, second magnesium, third calcium, fourth one is potassium carbonate. That's what I told. Group comparisons will be done. So answer is B option. Very, very important question. So please note down. So within the same group, as we go down the group, the thermal stability decreases. Thermal stability decreases. So as the thermal stability is decreasing, barium carbonate less than magnesium carbonate, less than calcium carbonate, less than potassium carbonate. So thermal stability increases down the group. What you can understand? Thermal stability increases down the group within the same group, increases down the group in second group, in group 2, increases down in group 2, and is lesser than group 1, less than group 1. Group 1, what are the elements we have? Potassium. So answer is second option. Very, very important question. This is previous IIT question now. So these are the types of questions we are getting. Next question. Still 3 questions are there from previous IITs. We'll discuss all those and then we'll wind up this class. Next question number 17. Question number 17. Previous IIT question now we are discussing. 1 mole of calcium phosphide. 1 mole of calcium phosphide CaP2 on reaction with excess of water, on reaction with excess of water gives Option A, 1 mole of phosphine, 1 mole of phosphine. They have given even balancing also. That's what they have said about moles. Next, option B, 2 moles of phosphoric acid, 2 moles of phosphoric acid, that is H3PO4, and option C, 2 moles of phosphoric acid, 1 mole of phosphorus pentoxide. 2 moles of phosphoric acid, and option D, 1 mole of phosphorus pentoxide, P2O5, phosphorus pentoxide. Now we need to write the equation, then only you can get the answer perfectly. So the answer is, so first let us write the equation now for this. I'm writing the solution. So calcium phosphide, calcium phosphide on reaction with 6 moles of water, it forms 3 moles of calcium hydroxide, 3 moles of calcium hydroxide, and 2 moles of phosphine, 2 moles of phosphine. So it is nothing but PH3. So second option, actually this should be not be phosphoric acid because already you are given phosphoric acid, it is 2 moles of phosphine. Second option is change the option, it is 2 moles of phosphine. So answer is B. Answer is what? B. Because 2 moles of phosphoric acid again have written, here also written. So it should be phosphine. So answer is B. Option B. That is 2 moles of phosphoric acid. Phosphine is formed. What is formed? Phosphine. Phosphine is a poisonous gas. Phosphine is a poisonous gas. Next question. Question number 18. Magnesium sulfate. Magnesium sulfate on reaction with ammonium hydroxide, on reaction with ammonium hydroxide, and sodium phosphate, that is sodium phosphate Na2HPO4, forms a white crystalline solid, forms a white crystalline, white crystalline substance, white crystalline substance. The formula is, its formula is option A, magnesium ammonium phosphate, MgNH4PO4. Option B, it is magnesium phosphate, Mg3PO4 taken twice. Option C, it is MgCl2 MgSO4, MgCl2 dot MgSO4. So there is no formation of this because there is no chlorine over here. Option D, it should be MgSO4. So what is the right answer? We have to check MgSO4 again. So answer we have to check now. So first option is MgSO4 NH4 PO4, MgNH4, that is magnesium ammonium phosphate. Second option is magnesium phosphate. So it forms magnesium sulfate on reaction with ammonium hydroxide, and this forms magnesium ammonium phosphate. It is called what? Magnesium ammonium phosphate. Next, last question for this session we are discussing now, question number 19 and 20. Two more questions we'll discuss, then we'll wind up this session. Which one of the following alkaline metal, which one of the following alkaline earth metal, which one of the following alkaline earth metal sulfates, earth metal sulfates has its hydration enthalpy. Hydration enthalpy. This is also previous IIT question. Hydration enthalpy greater than its lattice enthalpy. Greater than its lattice enthalpy. So option A, it is calcium sulfate. Option B, it is beryllium sulfate. Option C, it is barium sulfate. Option D, it is strontium sulfate. So the sulfate which is soluble, if hydration enthalpy is greater than lattice enthalpy, so here I am giving the hint. For this, the hint is if hydration enthalpy is greater than lattice enthalpy, the compound is soluble in water. The compound is soluble in water. So which is soluble in water? We have to check. That is the answer. So it's quite simple. That is the basic idea. So beryllium sulfate is having more hydration enthalpy. So answer is B. If hydration enthalpy is greater than lattice enthalpy, the compound is soluble in water. So in that case, it is nothing but beryllium sulfate. Remaining all are sparingly soluble in water. Last question for this session now. This question I have prepared by myself. Compound A on reaction with carbon forms compound B. This is carbon. It is graphite rod, carbon solid. This compound B on hydrolysis forms compound C. Compound C. This compound C, when passed through red hot iron tube, it forms compound D. Identify A, B, C, D. Identify A, comma B, comma C, comma D. This is carbon is nothing but you write here carbon highlight better to understand. Compound A plus carbon gives rise to compound B, which on hydrolysis forms compound C, which forms when passed through a hot tube compound D. So here the answer is for this I'll write the equation straight away. I have written on my own question. So calcium oxide plus carbon forms calcium carbide. This is compound B. This is compound A. This calcium carbide on hydrolysis forms ethane. So acetylene. This is compound C, acetylene. This compound C, when passed through red hot iron tube, it forms benzene C6H6. So this is our compound D. So answer is A is calcium oxide, B is calcium carbide, C is ethylene or acetylene, and D is benzene. So like these questions you will expect in the examination. So with this, I'm ending this session. So we have discussed almost 20 questions in alkaline earth metals. In the next coming sessions, we'll discuss more about alkali and alkaline earth metals. Thank you.